In this video, we're going to learn how to solve other radical equations. So, to solve equations of the form x to the m over n, which is a rational exponent, you would raise each side to its reciprocal power, n over m. Now, if either n or m is an even number, you have to write the absolute value of x, and I'll get into why in the first example. So, I have 3 times x plus 1 to the 2/3 equals 12. So to solve this, I'm going to divide each side by 3 to isolate that radical first, so I can get it in that form. So divided by 3, I have x plus 1 to the 2/3 equals 4. Now to solve this, I'm going to raise each side to the 3/2 power. If this was 2/3, you'll raise it to the 3/2 on each side of the equation. Now the reason why is this is going to become the absolute value of x plus 1 is because right now with x plus 1 to the 2/3, that numerator is a square, which makes this entire expression a positive number. So I know it has to remain positive. So when I get x plus 1, there's a potential for it to be negative. So to negate that, I just put an absolute value. On the right, I have 4 to the 3/2 power, which will be the square root of 4, and then raised to the 3rd power. So 4 can be also known as 2 squared. So another way you can also simplify this is to rewrite it as 2 squared, and you get x absolute value of x plus 1 is equal to 2 to the 3rd, which is 8. So to finish solving, I'll get rid of the absolute value by putting a plus or minus on the right side, because this will either equal positive or negative 8 on the inside. So I'll get x is equal to negative 1 plus or minus 8, which leads to the two solutions of negative 1 plus 8, which is 7, and negative 1 minus 8, which is negative 9. Now we do want to check both of these solutions. If I were to plug in 7 into my expression, when I'm checking, I'll get 3 times 7 plus 1 to the 2/3, which gives me 3 times 8 to the 2/3, which is 4. So 3 times 4 should be 12. And I check negative 9, I have 3 times negative 9 plus 1 to the 2/3. So it's 3 times negative 8 to the 2/3. And for that same reason I just mentioned before, that square makes this a positive number. So it'll also come out to be positive 4, which will be 12. So both solutions should work. Now let's check out the next example. We're going to isolate that radical first. So I'm going to subtract 1 and then divide by 3. So I have 3 times the 5th roots of x plus 1 to the 3rd is equal to 24. Dividing by 3, I'll now have the 5th roots of x plus 1 to the 3rd equal to 8. Now, to solve this, I'm going to rewrite this in exponential form so I can just use that reciprocal power way to solve. So now, rewrite this in exponential form, I'll have x plus 1 to the 3/5 power. That 5 should go in the denominator. And then I'll raise each side. So I'll have x plus 1 to the 3/5 equals 8. And if I raise each side to the 5/3 power, I can get rid of that radical, but you'll see here all the numbers are odd, so there's no way of it making it positive. So I don't need to worry about absolute value signs here. I'll just have x plus 1 equals 8 to the 5/3. 8 is also known as 2 to the 3rd power. So I have x plus 1 equals 2 to the 5th power, 32, leaving me with x is equal to 31. Now you do want to check that solution, so it's checking it out. If I were to plug that in, I would get 3 times the 5th roots of 31 plus 1 cubed, which is just 32. So I'm actually going to cube it last to make the math a little easier. The cube root of 32 is 2. So you have 3 times 2 cubed, which is 8. So 3 times 8 is 24 plus 1 should equal 25. So that does work as a solution. Now I'm going to get to my word problem at the end. I'm going to go over this example first. So again, I want to isolate my radical, which is the x minus 1 to the 4/3, by subtracting 4 and then dividing by 2. So I'll have x minus 1 to the 4/3 is equal to 16. And I'm going to raise each side to the 3/4 power to cancel out the 4/3. And since there is an even number, I have to use absolute value, because again, that 4th power to begin with made it always positive. So I'll end up with the absolute value of x minus 1 is equal to 16 to the 3/4. 16 is also known as 2 to the 4th. So I could replace 16 to the 3/4 with 2 to the 3rd, also known as 8. So x minus 1 equals plus or minus 8. Add 1 to both sides, and you get x equals 1 plus or minus 8. So my two solutions are 9 or -7. So 1 plus 8 or 1 minus 8. I will go ahead and check both of these. So we have 2 times 9 minus 1 to the 4/3 plus 4. So 2 times 8 to the 4/3, which will be the cube root of 8, which is 2, then to the 4th, which is 16. So 2 times 16 plus 4, which would be 32 plus 4, which is 36. So 9 works as a solution. And I can also check -7. So 2 times -7 minus 1 to the 4/3 plus 4 gives me 2 times -8 to the 4/3, which the cube root of -8 is -2, but when you raise it to the 4th power, it becomes a positive 16. And this will also lead to 36. So both solutions work. Now lastly, for my word problem, we have for meteor crater in Arizona, the formula D is equal to 2 times the cube root of V over 0.3. Relates the diameter of the rim, D, to the volume in cubic meters of the crater. So what is the volume of meteor crater when its diameter is 1.2 kilometers? So we know the diameter, but we were looking for the volume. So one thing I can do is solve this equation for V and get an equation for volume. So I will first divide each side by 2. And then to get rid of the cubed root, I'm going to use its reciprocal power, 3, because that's 1/3. So I'll raise each side to the 3rd power, which will give me D over 2 cubed is equal to V over 0.3. And then you can multiply each side by 0.3. And voila, we have a formula. V should be equal to 0.3 times D over 2 cubed. Now, what is my diameter? Well, it's given to me as 1.2 kilometers, but this formula wants the diameter to be given in meters. So I need to convert this. So if I multiply it, every 1 kilometer is 1,000 meters. So I'll have to multiply by 1,000. And the diameter is going to be 1,200 meters. So when I place that into my formula, I'll have 0.3 times 1,200 over 2 cubed, which is the same as 0.3 times 600 cubed. So the volume of this canyon, I'm going to get my calculator, would be 0.3 times 600 cubed. 64,800,000 meters cubed. Very, very large. So 64,800,000 meters cubed. And that is how you solve other radical equations.